Intermediate Algebra Section 1.7, multiplying or dividing with scientific notation. In this example, they're asking us to multiply these two numbers that are in scientific notation. Within the parentheses, we do have multiplication, and a parenthesis next to one another implies multiplication as well. So one approach is to simply use commutative property and multiply the like terms together, similar to what we did in scientific or in exponential notation. You might want to grab your calculator to do the multiplication of 9.25 times 4.5, resulting in 41.625. We have common bases multiplied together. That means we can add our exponents. 6 plus 7 is 13. And this isn't in true scientific notation because we have two digits to the left. So we're going to have one more power of 10 added on. So our final answer could be 4.1625 times 10 to the 13th plus another power of 10, or 10 to the 14th. Now that's with a low-tech calculator. However, if you have a scientific or graphic calculator, it allows us to enter numbers that are in scientific notation. To do so, you might see an EE key, you might see an EXP key, or you might even see a calculator that has 10 to the and with a little box on it. This model that I have here actually has an EXP key here at the bottom that I'm going to press, and I'll show you how that looks on this calculation. So if I put 9.25, and now I'm tapping that EXP key at the bottom, EXP, and what it does is it puts an E. This is scientific notation, and in the computer world we have something known as E form, and it's very similar to our scientific notation, where instead of writing it scientific, the E form would be 9.25 E6 would be an equivalent, and that's what this calculator is essentially doing. The times 10 is built into the function of that key. By simply tapping the EXP key, I've got the times 10. Now all I need to do is enter the 6 to say it's to the 6th power. What are we doing? We're multiplying, so I'll hit the multiplication key of 4.5, and instead of putting a times, you tap your exponent or scientific notation key, whatever version your calculator has. In this case, I'm just hitting the EXP and indicating the power that it's raised to. So I'm tapping in a 7. So again, on this example, I hit the 9, which we can't see any longer, 9.25, tap the power key or the exponential key for scientific notation, whichever version is on your calculator, entered the power that the 10 is raised to, then and only then I hit the X, the multiplication key, which is indicated with the X there, 4.5, EXP, the power that 10 is raised to, and I'll hit the equals. And on the display, and again, different calculators represent this differently, but it's a 4.1625, and I have a little times 10 there. May not be very clear, but I have a smaller 14. That's the exponential power. Some calculators will not put the times 10. They'll have the smaller number, looks like an exponent, and this might be what the display looks like, which we know that this isn't the same. 4.1625 to the 14th power is not the same as the correct answer. So if you have a calculator that does this, be sure that you rewrite it into a recognizable scientific notation form. Let's look at one more example where an application comes into play with scientific notation. In this problem, it's telling us that the Amazon River discharges approximately 250 million cubic feet of water per minute. How much water is discharged in a week? Express the answer in scientific notation. So we're given this discharge rate, 250 million cubic feet. Well, let's write that out just in standard form. 250 million means that there are 6 zeros following that number. Putting that in scientific notation, with our decimal over here on the far right, we're going to move the decimal place and powers of 10, 3, 6, 7, 8. So 250 million is the same as 2.5 times 10 to the 8th power, and it says cubic feet, so feet to the 3rd power per minute. And they're asking us to convert this discharge rate from per minute to per week. And most of us don't know how many minutes are in a week. So we need to go through a series of conversion factors. And the first one is to convert minutes into hours, because probably you don't know how many minutes are in a day, let alone a week. But I do know, as most of us do, that there are 60 minutes in 1 hour. We have equivalent values over one another, so this is just a special one, our conversion factor. And the reason the 60 minutes went in the numerator is so that the minutes will cancel out, and this would be per 1 minute. Minutes will cancel out. So now we have a discharge rate of cubic feet per hour, but we don't want hours. Hours to days seems like the next level of conversion. There is 24 hours per 1 day, and to cancel out hours, we'll put the 24 in the numerator over the 1 day. These are equivalent values, so it's essentially a fraction equal to 1, but it allows us to convert our factors. And we're almost there. We have days and we want weeks, 7 days in 1 week. To cancel out the days that are in the denominator, we'll put the 7 days in the numerator and the 1 week in the denominator. Days are now canceling out. So to solve this and to answer in scientific notation, we need to multiply the numerators together. The denominators are all 1, and dividing by 1 is 1. So essentially it's multiplying the numerators together. And if we grab, again, that scientific calculator, entering this first number, 2.5, and again, for this model calculator, to enter that scientific notation, I've entered 2.5. I'm tapping the EXP key, which shows an E in the display, and then only the power that the 10 is raised to. So this is the E form or equivalent version of scientific notation. And now I'm going to multiply by the rest of the values in this problem. Multiply it by 60, the number of minutes in an hour, times it by 24, the number of hours in a day, and then multiply it by 7, the number of days in a week. Tap the equals, and here the final answer is 2.52 times 10 to the 12th power for our final answer. So 2.52 times 10 to the 12th, already in scientific notation. Cubic feet per week would be the correct answer for this problem.